Now we're going to be starting part 2 of this examination preparation paper, and again this has a difficulty level of 1, so it's again the most basic type of questions you'd get in your exam, so make sure each and one of them are clear in your minds, okay? So starting with question 10, simplify this expression. Well, this one I would actually get rid of the brackets first, so it's a cubic, so inside all of these terms, 2x and y squared, we're going to cube them. So it's going to be 3 out the front as it is, 2 cubed, x cubed, and y to the power of 2 cubed. So you can multiply the 2 and 3 to the index of the y. Okay? And you should know that 2 cubed is 8, so 8 times 3 is 24. And then the x cubed y to the power of 6 remains as it is. And that's it. So how easy was that? That was question 10. Question 11. Okay, we're factorizing this expression and it has 4 terms. And guys, remember, I told you that whenever you see an expression with 4 terms, try to group them into 2's. Okay, so group them 2's and factorize it individually and see what you get. So what I'll do is try to group these 2 together and these 2 together. So see how I factorize that one individually? See, the common factor is x. So we have a plus 4 left inside. And here, negative 3 is common. I like to take the negative out as well, so it's going to be negative 3 out the front, a, and then it's going to be plus 4, because 12 divided by 3 is 4, and negative positive will make the negative. So that's why that one's a positive. Just keep an eye, don't make that mistake of making that as a negative, okay? So make sure that's a positive. And now guys, you can all see that the common factor is a plus 4. A plus 4 is common. So you can take a plus 4 out to the front or out to the back, okay, because it's a common factor like you do with any factorization. You take the common factor out, don't you? So I'll take a plus 4 out and x minus 3 is left. So x minus 3 is inside the other bracket. And that's it. That's the final factorization for this question. Okay, so the key thing is to group them into 2's for any expression with 4 terms. Question 12. Okay, we want to try to simplify it basically. So, I want to make a single fraction, and to do that we need to make a common denominator. To do that, we can simply just multiply the denominators together, don't we? We can multiply the denominators together and then cross multiply. So if I multiply the 7 and 9 together, I have to multiply this by 9 and this one by 7, don't I? So that's why I did that here, okay, times 7. And then all I need to do is simplify the numerator. So 9 times 2k, 18k, 9 times 5 is 45. And then etc, negative 7k, and make sure that negative negative always becomes a positive, so positive 56 for that. And now all we need to do is gather the like terms. So 18k minus 7k, 11k, and 45 plus 56 is 101. So that's all over 63. That's the final answer, because we can't simplify any further than that. And that just concludes the question. Okay, so that was pretty simple, making it into a single fraction, right? Question 13. Okay, we've got some absolute value questions. Now, all of you should know, as I've told you so many times in the past, that absolute bars mean whatever we put inside will become positive, even if it's a negative value. So this number here, 3x minus 2, could be a negative number or a positive number. Okay, and even if it's negative, we could change it to just positive because of those absolute bars. So 3x minus 2 could be positive 1, or 3x minus 2 could be negative 1. Okay, it could be negative 1, but because of those absolute bars, we know that it's definitely going to be positive 1. So we have 2 equations to solve, so solve them individually. Here, move the negative 2 over, so it's 1 plus 2 to make 3. Divide both sides by 3. To get x equals to 1. Now here, move the negative 2 over, so negative 1 plus 2 is 1, and then to get x, divide by 3. Whoops, what is that 3 doing there? Trying to ignore that one. Okay, so x is simply going to be 1 over 3, a little bit of a mistake there. Anyway, so we've got 2 values, so therefore x equals to 1 or x equals to 1 over 3. Okay, and that's it, guys. That's pretty much it. So there's two cases that you must always consider with absolute value questions. And that was a little mistake there. Question 14, expand and simplify. Okay, we have something squared. In that case, just before we start, guys, you should all remember, if it's something squared, it's a squared plus 2ab plus b squared. I've said this so many times, but I'll just write that down just in case. And therefore this one, a is 2 root 6, b is 3 root 2. So I'll do a squared, so 2 root 6 squared. So 2 squared and root 6 squared, I'll just write that separately. And then we have 2ab. So 2 times a times b plus b squared. b is 3 root 2, so I have 3 squared root 2 squared. I'll just do that separately as well. And now just simplify, guys. So 2 squared is 4, root 6 squared is 6. Remember, the square and the power of 2 cancels each other. And then 2 times 2 times 3 is 12. And root 6 times root 2, so you can gather your surds together. So root 6 times root 2 is root 12. And then 3 squared is 9, root 2 squared. Again, the square root and the square cancels, so it's just 2. Very easy simplification. So I can now say that 4 times 6 is 24. And here, what do we have? Oh, here, root 12 we can simplify, because root 12 is 4 times 3, isn't it? And we know that root 4 is 2, so the 2 can go out and the 3 can remain. So therefore, this one here will be 12 times 2 root 3. So 12 times 2 is 24. That's how I get that one, right? And root 3. And then we know that 9 times 2 is 18. Gather the like terms. 24 plus 18 is 42. So 42 plus 24 root 3. Okay, so take a look at that one. Just remember this stuff, okay? So you don't have to do lots of working out. That's question 14. Question 15, rationalize the denominator. Very easy. This is a very repetitive question, and you should see that's repetitive in your exam as well. Okay, so you'll see this a lot. Now root 7 plus root 3, what's the conjugate of that? It's root 7 minus root 3. So make sure you multiply that on the top and the bottom. So numerator and denominator, just like this. So we'll expand. So it's going to be, I like to use some brackets here just so I don't get confused. This times this is going to be root 7 squared minus 2 times root 7 times root 3. Okay, so 2 times root 7 times root 3 plus root 3 squared. Okay, so this is just an expansion like we did in the previous one, but remember this time it's a minus b squared, whereas the previous question we used a plus b squared. So the only difference is this is a negative. Okay, so I'll just write this just in case. So that's what I'm doing here, just using that expansion. So, and then finally b squared, so it's going to be root 3 squared. And denominator, this is root 7 plus root 3, root 7 minus root 3. How do we expand that? It's just going to be root 7 squared minus root 3 squared. Okay, so just some basic knowledge we're using there. And then let's just simplify. Root 7 squared is just 7. And here we can multiply the surds together. So root 7 times root 3 is root 21. And then of course root 3 squared is just 3. And root 7 squared is 7. Root 3 squared is 3. So 7 minus 3 simply becomes 4. Now gather your like terms. 7 plus 3 is 10. So that's all I did there. And let me just rub all this out. And let's simplify. Oh, we can see that 2 is a common factor for all 3 terms, so I can divide everything by 2. So we have 10 divided by 2, which is 5, 2 divided by 2, which is 1, and 4 divided by 2, which is 2. So that's the final answer. Okay, so make sure you simplify as much as possible all the time. Okay, so that was question 15. 16. Find the value of a such that root a is root 18 minus root 2. Okay, well, we might as well just simplify this expression there. So root a is going to be this one, but you see that root 18 is the same as 9 times 2. 18 is 9 times 2, isn't it? And I know that 9 is a square number. Because 9 is 3 squared, I know that the square root of 9 is going to be simply 3. Okay, so that's why I took the 3 out there. And now I have root 2 left inside the third, or the root. Root 2 just left. So see how these two are like terms? So it's going to be 3 root 2 minus 1 root 2, which is 2 root 2. But that's not it. We can't, make sure you don't say 2 is A, because see how this one has 1 outside? If there's nothing outside, it just means 1, right? And this has 2 outside. We want it to be 1. So how do we put 2 back inside the root? Well, we'll have to square it, so make sure you square the 2 and put it back inside. So 2 squared is 4. Okay, so 2 squared is 4 times 2 is 8. So that's how we get that. So just remember this one. It's the same as 2 squared. Okay, 2 is root 2 squared, which is root 4, which is root 8. Okay, just for those who need a little bit more hand. And then therefore you can tell me, guys, what is A? A is just 8. Okay, so whatever's inside the root is A. So that's the answer to the question. Okay, so again, not too hard. Let's continue. Question 17. Okay, it's a cubic factorization. Guys, remember, I know all of you know this, but just in case, I will tell you. But make sure for those who don't know, you must remember from now on. A minus B, A squared plus AB plus B squared. So we'll just use this. So please tell me that you've already memorized this. This is very, very important, guys, okay? So make sure you memorized it first. So we'll do it. A in this case is X, B in this case is 3, because we know that 27 is 3 cubed. So that's why we have X minus 3 here. Okay, A minus B, so X minus 3. And then A squared is just X squared. AB is going to be X times 3, so it's 3X. And then B squared is 3 squared, so 9. And that's it. We only need one single step there, as long as you memorize this one. Okay, so please, very, very important. So that concludes question 17, and that also concludes part 2.